Alright folks, hello and welcome to this video lesson on section 4.1 to 4.2 on graphing quadratic functions. This is going to be an introductory video, and then in class we'll delve deeper into graphing these functions. So let's get to the lesson. Remember, you should copy down these notes and important examples into your notebooks so you have them for future reference and for study. First, I want to introduce the idea of a parent function, which we're going to use some old graphs to cover first, and then we'll look at it with a quadratic. But a parent function is the simplest function of a family of functions. And to be a good grapher, you have to memorize their shapes and their properties. So any parent function, the simplest function of a certain type, you really need to know. And the first one is just y equals x that I have graphed here, which is a line through the origin with a slope of 1. And we call this the parent function, the parent linear function, because it is the simplest type of line as far as the equation is concerned. Any other line that you can graph can be looked at as a line that's a transformed equation from this one. Of course, you could change the slope, you could change the y-intercept, and you get a different line. But that's the basic, most simple line you can graph with the equation y equals x. Next up, we have y equals the absolute value of x, and for this one, we got pretty good at looking at that parent function because you had to memorize the shape in order to transform these graphs. So we know it forms the V shape with a slope of 1 on the part of the ray that's in the first quadrant, and it has a slope of -1 for the part of the ray that's in the second quadrant. And that's the parent function of absolute value. So my point of saying this is that all the other types of equations that you can make for absolute value and for lines can be made by transforming y equals x or transforming y equals the absolute value of x. Granted, for these type of lines, you could have a horizontal or vertical line, which will be a slightly different equation format. So now let's look at quadratics. The parent function for quadratics is y equals x squared, and it forms a curve known as a parabola. And a couple things I want you to take note of here is that quadratics are defined as functions with a degree of 2. Or if you have a quadratic equation, it would be an equation where the highest degree term is 2. So you'll have an x squared, a 3x squared, something with an x squared in it. And the type of curve it forms, that U shape, is going to be called a parabola. So let's look at the graph. First of all, the fundamental way of graphing, when you don't know what something looks like, is to make a little xy chart. And for y equals x squared, if we were going to look at, let's say, -2, -1, and 0, and then also +2, +1, and 0, what are those outputs going to look like? Well, -2, when you square it, you get 4. You square 1, you get 1. 0 is 0. And then +1 and 2 give you 1 and 4, respectively. And when you plot those points, we have 0, 0. We have 1, 1. We have 2, 4. And I'm approximating a little bit with this sketch, but you get the idea. -1, 1, and -2, 4. If you were to sketch the curve that goes through those points, it's going to form that U shape, which is known as a parabola. Now, it's not perfect there, but it gets the job done. So that's the standard parabola. I want you to notice a couple properties about this parabola. First is that it's symmetrical. Okay, it has symmetry about the y-axis. And the axis of symmetry, if we were to draw it, it would be a dotted line going on the y-axis. Okay, actually the y-axis is the axis of symmetry. And that would be the line x equals 0. So it's symmetric about the y-axis or about the line x equals 0. It has a vertex, second property, or a turning point right there that I'm highlighting in blue. In this case, its vertex is 0, 0. Every parabola is going to have that turning point where the curve is going one way, and then it's going downward, and then it switches, and it's going upward. Or it's going upward, and then it switches, and it's going downward. And that point is called the vertex. The last thing I've noticed is this 1, 3, 5, 7 pattern, which is kind of a helpful trick when you want to graph these things quickly. And for that, I'm just going to redraw my XY chart and label up to 1, 2, 3, and 4. And if you plug in the squared values, the y value here will be 1, 4, 9, 16. And if you notice the increases, the first increase, I should have started at 0. The first increase, remember, 0, 0. That's where it could start. But the first increase from 0 to 1 is it's going plus 1. The second increase is plus 3. The next increase is plus 5. And the next increase is plus 7. So if you want to kind of memorize a quick way to graph these, generally with graphing I'm going to require 5 points on a parabola, 5 clear points. You can start at the vertex, and then you can just go up 1 over 1, and that'll be your first point. To get to the next point, you go up 3 over 1, following this pattern, up 1, up 3, and then to get to the next one, you would go up 5 over 1, and then up 7 over 1, and etc., and etc. And that will work whenever it's a parabola that has this form. Now, recall how to transform a function f of x into the function a times f of x minus h plus k. That's going to look a little bit different. So we can use this idea to transform and to graph quadratic functions in what's called vertex form. So it's not always going to look just like y equals x squared, the parent function. We're going to throw some numbers in there, as per this equation, some extra parameters, and then you're going to be expected to graph it. When this is a parabola, this f of x is a parabola, this is going to be known as vertex form. And I'll show you a little bit more about that on the next slide. Okay, so on this slide at the bottom, the first thing I'd like you to get down, maybe put it in a box on your notes, is the vertex form equation of a parabola. So this is not just any f of x. This is, you know, it's a parabola. It's going to look like this equation here. Y equals a times the quantity x minus h squared plus k. And hopefully you're going to remember or see that this is very similar to our absolute value transformations. So let's look at an example. In example 1, we're going to graph y equals x plus 4 squared. And now looking at our general form, you need to recognize that the h comma k still stands for the vertex. Whether it's a parabola or absolute value function, that h comma k is indeed the vertex. And in this case, so the number next to the x, you're going to switch that sign, and that'll be negative 4 here. And then there's nothing added here, so it's really like a plus 0. So that'll be a negative 4 comma 0. So that's going to be our vertex. And you can use that strategy just like you did with the absolute value functions. So I'm just going to go over here, we'll call that negative 4. Clean it up a little bit. And that's my first point that I plotted. Then my strategy is going to be, if I can find 2 points to the right of the axis of symmetry and 2 points to the left, well, that'll give me my 5 points. So it's pretty conventional to make a dotted line representing the axis of symmetry of the parabola. It always goes through the vertex. And now I just want to find a couple points to the right or left. Using my technique of going up 1 over 1, I can arrive at this ordered pair, which is negative 3 comma 1. And remember, that's from my 1, 5, 3, 7 step notation, or step trick from the previous slide. And you can use that as well, or you can make an XY chart if you wanted to find some other values. For example, you could have made an XY chart and just plugged in negative 3 and see what resulted in the equation. And you'd find that it comes out to positive 1. That's perfectly legitimate as well. The step way is just a shortcut. And then next, I would go up 3 and over an additional 1, and that's going to put me at negative 2 comma 4. Again, if you were using the XY chart, you plug in negative 2 for the x, and you'll find out the answer is positive 4. And so that's 1/2 of the parabola, and you can merely mirror that, count the points to the opposite side, so you just go over 1 and another 1, you go over 2 and another 2, bump it over, line it up, and that is your other half of the parabola. You simply copy it to the other side. Now it's probably easier to do with graph paper, but if you're sketching just like I did, and you mark the ordered pairs, that would be a perfectly acceptable final answer. Well, you know what, we probably should mark the other ordered pairs too. So this one over here would be negative 5 comma 1, and then this one up top here would be negative 6 comma 4. Just using that symmetry, I was able to get those ordered pairs. Now let's look at a second example. In this parabola, again, I'll start with the vertex, which is going to be h comma k. And in this case, that'll be 1 comma negative 5. Remember, you switch the sign for the number next to the x, and the part on the outside, you're just going to keep that as it is, to be your y coordinate, and that's how I'm going to graph that vertex of 1, -5. And I just chose a scale accordingly based on what I thought was going to fit neatly in this problem. I noticed that the parabola is going to be opening downward, as is indicated by this negative sign. So with a parabola, just like absolute value, the negative sign will indicate that it opens downward. And if you have a positive sign there, it's going to open upwards. Kind of like when we had absolute value, it either opened up or it opened down. So in this case, it's an opening down parabola. So I chose a bit of a bigger scale on the y-axis so I can make sure I can fit a couple of points in. And then once I have my vertex, I'm going to choose either 2 points to the left or right and use that XY chart technique. I could use the step trick, but I don't really know how to handle this -2 with the steps. Do you know how to handle that -2 with the steps? Well, perhaps you can try some things and figure it out. Because if you figure out that pattern, you can actually handle any coefficient of the parentheses here. Any number in front, you can handle it with the steps trick. But you're going to have to figure out that shortcut on your own if you want to use it. Next up, I want to plug in x, 2 and 3. All right, the reason I'm picking 2 and 3 is because they're very close to 1 on the x-axis, and I don't want to go too far out because my numbers will get really large or really small and they'll be hard to plot. So if I substitute 2 in for x, let's see, that's 2 minus 1 squared is 1. The -2, it comes out to -7. If I plug in 3 for x, we get 4, which gives us -8, minus 5, and it comes out to -13. You can check the arithmetic there, but those are going to be the next 2 points I plot. So 2, -7. And then we have 3, -13. Apologize for the messiness. It is just a sketch, but try to be as accurate as you can. It's a little tougher to draw this on the computer, but you should get a half a parabola opening like that. Let's throw in my axis of symmetry, and you can recopy the parabola to the other side, moving this point over here to 0, -7, and then this point will move over here. I missed a little bit, but that's going to be, let's see, if I move 2 and then another 2, that's going to be -1, -13. And then I'll copy the other half of the parabola, and that is my graph. All right, so those are 2 examples you're going to use to graph parabolas in vertex form. Lastly, let's just summarize the lesson. In this video lesson, we saw what parent functions are, the simplest types of a graph. We saw a line parent function, y equals x. We saw a absolute value parent function, y equals absolute value of x. And now we added the quadratic parent function, which is a parabola, y equals x squared. Next, we really analyzed that graph, y equals x squared. We saw some properties of it, that it has a vertex, an axis of symmetry, and various rates of increase, which you can learn shortcuts for if you want to manipulate those steps. Otherwise, you can use an XY chart to graph. And then lastly, we saw 2 techniques of graphing, or 2 examples of graphing when the parabolas had equations written in vertex form. That's all for our summary of our intro to 4.1 to 4.2, and thanks for watching this video lesson.